We're going to be discussing the X-ray tube and its components, what it actually consists of, and how X-rays are made. This is from an assignment that we actually did last semester, and I thought this would be perfect for this presentation. Everything is drawn out, labeled, and I just thought it would be a great way to display all these components and how they work together to create an X-ray. Let's go ahead and start with the cathode. Now, the cathode is negatively charged, and it actually heats up through a process called thermionic emission. Now, in this process, it creates a cloud of free electrons, which that is where the filament comes into play. So the filament is a coil of wire made of tungsten, because you need a material that is able to withstand the heat created in the cathode. So it is made of tungsten, and it actually is what emits the electrons over to the anode. Now, in this picture, I only drew one filament, but typically there are two filaments in an X-ray tube, more commonly today, and that is called a dual focus X-ray tube. And we'll go down and show that. Okay, this is a picture of the cathode, and you can see there are two filaments here within the cathode. Now, this is the smaller one. It's about 1 centimeter long, and it is its purpose is for smaller exposures, so smaller mass and for smaller body parts. Now, this is the larger filament. It is double in size, it's about 2 centimeters long, and it's meant for larger exposures, so larger mass and for larger body parts. Now, in this image, you can see that they're sitting back in this area, and that is called the focusing cup. Each of them have a focusing cup, and without these, the electrons that are created would just be scattered out everywhere into the X-ray tube. So what they do is they are negatively charged, and it actually compacts those electrons into the X-ray beam. Okay. Now, from here, we'll go to the anode. Now, the anode, it can either be stationary or rotating. Now, more preferably today, rotating anodes are more ideal, mainly because if you have a stationary anode, the electron beam coming from the cathode hits the same spot every time an exposure is made, which will wear down very quickly and will not last as long as a rotating anode. Because the rotating anode spins during an exposure, and that electron beam can hit different parts of that rotating anode. And I'll show you here. Okay. This is a normal anode disc. You can see this little gray circle around it. That is the focal tract. That is where the electron beam coming from the cathode hits the anode. Now, this is a picture of an anode disc that has worn out over time, and you can actually see etching and cracking throughout the focal tract. And whenever this happens, it can seriously degrade an image. Okay. Along with that, we have the induction motor. Now, the induction motor actually induces the anode to spin. So this is the rotor, and it is connected to the anode disc. Along with that, there are two stators, one on each side. And each of these stators, they create an opposing magnetic field, and that actually causes the rotor to spin. Then we have these bearings, and these bearings allow the rotor to spin more freely and more smoothly. As it's connected to the anode, it creates the whole thing to spin, and what we just talked about, causing the big focal tract all the way around. Okay. Now, one thing I do want to mention is whenever you make an exposure and you have the button, if you go halfway down, but it doesn't create an exposure, but it's called rotoring because it spins the rotor. Now, over time, you don't want to do that too much, because excessive rotoring can cause these bearings and the filament to really wear out. Okay. Now we're going to talk about the glass envelope. Now, the glass envelope is this little purple line all the way around. it creates an air-free vacuum, and it plays a really important role in preserving all the components in the X-ray tube. And that's because it prevents oxidation and corrosion within the tube. Now outside of that, we have the tube housing, which plays a couple roles. First, it protects everything inside the tube. But another main reason is that it prevents X-rays from being emitted all out into the room. So it not only protects everything inside, but it protects everyone outside and protects these electrons from shooting out. And now we have the window. Now the window is a gap that shoots down from the anode. Now when this electron beam comes over and hits the focal spot on the anode, it shoots down through this window and hits the target, and that's where the useful beam is actually emitted. And this is how the X-ray tube works.